Today's lesson will focus on the properties of isosceles and equilateral triangle. We'll use these properties to solve for the missing angle and missing sides. Let's review the properties of isosceles triangles. Isosceles triangles have at least two congruent sides. These congruent sides are called the legs of the isosceles triangle. The legs of the isosceles triangles are connected with the angle called the vertex angle. The side opposite to the vertex angle is called the base of the isosceles triangle. The two angles formed by the base and the congruent sides are called the base angles. So if these two sides are congruent in the isosceles triangle, it will be referred to as legs. The angle connecting these legs will be called the vertex angle. The side opposite to the vertex angle is the base of the isosceles triangle, and the angle formed between the base and the legs will be the base angle. One of the properties of isosceles triangle is that there are two congruent sides in an isosceles triangle. The isosceles triangle theorem states that if two sides of a triangle are congruent, then the angles opposite to those sides are also congruent. That means this angle is equal to this angle. Just because the sides opposite to those angles are congruent, these two angles are also equal. Converse of the isosceles triangle theorem is the opposite of isosceles triangle theorem. Remember, isosceles triangle theorem states that in an isosceles triangle, if two sides are congruent, the angles opposite to those sides are also congruent. Converse of isosceles triangle theorem states that if two angles in an isosceles triangle are congruent, the opposite sides to those angles are also congruent. Converse means opposite. So converse of isosceles triangle theorem is just the opposite of isosceles triangle theorem. In the question below, we have to find two unmarked congruent angles and two unmarked congruent segments. Let's focus on triangle ABC. In triangle ABC, we have side AB congruent to side AC. That means the angles opposite to those sides are also congruent. So measure of angle ABC is congruent to measure of angle ACB. Please make sure to put the vertex in the middle, and this sign is the congruency sign. Now let's focus on triangle ADC. In triangle ADC, angle ADC is congruent to angle ACD. That means the sides opposite to those angles are also congruent. So AC is congruent to AD. Let's review the properties of equilateral triangle. A triangle is equilateral if and only if it is equiangular. An equilateral triangle is a triangle in which all three sides have the same length. This means that the sides are congruent in an equilateral triangle. If the sides are congruent, the angles opposite to those sides are also congruent. So the three angles in an equilateral triangle are congruent. This means they are equiangular. The angles are equal. Each angle of an equilateral triangle measures 60 degrees. Since we know that the angles in an equilateral triangle are equal, let's assume the angles to be x. Let's set up the expression to solve for x. X plus x equals 180. Let's combine like terms. So 3x equals 180. We'll divide by 3 on both sides to solve for x, and x equals 60 degrees. So the measure of each angle in an equilateral triangle is 60 degrees. Let's use the properties for isosceles triangle and equilateral triangle to solve question 1. In question 1, we have to solve for x and we have to solve for y. To solve for x, we need to find this angle first. In the triangle, we have two sides given as congruent. That means AB is congruent to AC. If AB is congruent to AC, this means that the angle opposite to those sides are also congruent. So if 2x is opposite to side AC, this means that the angle opposite to AB is also 2x. Let's set up the expression to solve for x. 2x plus 2x plus 2x equals 180. Combine like terms on the left-hand side. 6x equals 180. And last step will be to divide by 6 on both sides. So x equals 30. Notice that I did not put a degree symbol on 30 just because x is not representing the angle in the triangle. 2x is the angle, x is not the angle, so we do not put degree symbol on 30. Let's erase this so we can set up the expression for y. To solve for y, we have to look at the angles. So one side of the triangle is 4y minus 5 and the other side of the triangle is 3 inches. We know the three angles in a triangle, all three of them are 2x. That means all angles are congruent. If the angles are congruent, the sides opposite to those angles are also congruent. That means 4y minus 5 is equal to 3. To solve for y, we have to add 5 both sides. So 4y equals 8, and last step will be to divide by 4. And that gives us y equals to 2. Let's solve for x and y in question 2. In question 2, to solve for x, we first need to find this missing angle. We know that these two sides are congruent. If these sides are congruent, that means the angle opposite to those sides are going to be congruent. So the angle opposite to 4y minus 2 is 6x plus 8. Therefore, the angle opposite to 2y plus 2 is also 6x plus 8. So let's set up the expression for the angles. 6x plus 8 plus 6x plus 8 plus 80 equals 180. Combine like terms. So we'll have to add 6x and 6x together and the constants together. So 12x plus 96 equals 180. To solve for x, we'll have to subtract 96 both sides. So 12x equals 84. And the last step will be to divide by 12. So x equals 7. Again, please don't put the degree symbol on 7 just because x is not representing the angle. It's a part of the expression 6x plus 8. Now let's set up for y. For y, we know that the sides are congruent, so we'll set it up equal to each other. So 4y minus 2 equals 2y plus 2. We'll combine like terms. So we'll subtract 2y on both sides. So 2y minus 2 equals 2. Add 2 both sides. That will give us 2y equals 4. And last step will be to divide by 2. So y equals 2.